In this video, we want to look at hyperbolas, and this is part one. This will be a two-video section. And if you understand ellipses, how to find the center, the A, B, and the C, how to graph ellipses, hyperbolas are just a small difference. First off, our definition of a hyperbola is a set of all points where the difference of the distances from the foci is constant. Remember, ellipse was the sum of those distances. So the way a hyperbola works is if you have your two foci and you look at some point on the hyperbola, these distances from the two foci, if you subtract those two distances, you always get the same thing. So even if you have a point way out here and you were to look at the distance to one foci and the distance to the other, and you subtract them, you always get the exact same thing. Now what that means is hyperbolas kind of shoot off forever in these different directions. And you'll also notice the hyperbola kind of looks very similar to a parabola, but there's two of them going in opposite directions. So let's just start off right with an example of a graph of one, and then we'll kind of work our way back to the formulas, because some of this is no different than what we've done before. So first off, our center, just like before, with an ellipse, is 1, 2. That is no difference. You look at the number underneath the x, which is 4, so the square root of that's 2. So in the x direction, you go left 2 and right 2. Underneath the y is 16, so you go up 4 and you go down 4. All of that is exactly like an ellipse. Now, from this point is where things change a little bit. So let's look at some of our changes as we go through. So first off, you'll notice the first change is c squared is a squared plus b squared. The second change you'll notice is the a squared is always first. That has to do with subtraction, the order matters. Addition, it doesn't. So you'll notice if the a is underneath the y, it goes first. If it's underneath the x, it goes first. Our center is still HK on both. Notice the second one here is a little harder because now my H is over here with the X. H is always with the X, K is always with the Y. So our direction, if the X is first, if the x is squared, as in this example, then our hyperbola is going to open left and right. Okay, so this will be left and right along the x-axis. If our y is squared, this is going to open up or down. Now to find the vertices, we're going to add and subtract RA. Now, if you go back here, you understand RA is underneath our X because X is first. So our vertices in this case are going to be these 2 points. So our vertices are going to be 1 plus or minus 2, 2. Because our A is 2, our B is 4. So back to our formula here, our vertices are going to be H plus or minus A. And if it opens up or down, we're going to add and subtract A to our K. Our foci will work the same way as our ellipses did. We will add and subtract C to the same variable K or H that we did for our vertex. So back up here then. That's going to show us that this opens left or right. Now, how do we graph these? This is the part that's a little different or interesting, okay? So we know this is going to open left or right, but how does this open? Does this open like this? Does it open like that? We don't know. So what we're going to do is we're going to draw some lines to help us. Now, what I'm going to do is I'm going to use my 4 points here, like we think about making the ellipse, and I'm going to draw a box through these 4 points. This is not part of my graph. This is just helping me graph it. Next, I am going to draw diagonals through this box. So I'm going to use these right here. So if I use diagonals through the box, one that way and one that way. And now to draw my ellipse, I'm going to use these diagonals, which are actually asymptotes. So my hyperbola goes towards, if I can get it to draw correctly, they're going to come around through here and towards these lines. So this box and these asymptotes, and I can't draw these very good, like I said, I'm looking for all this information, not necessarily your artistic ability, and I'm really struggling to make these look good right here. Those black lines are the graph of the hyperbola. The last thing here I need is the focus. And to find the focus, I'm going to add and subtract C to get my focus. Now, you remember C now is A squared plus B squared. Because there's a minus in the middle, it's the opposite. So this is C squared would equal 20. So C is the square root of 20. And notice now the square root of 20 is 4 something. So 1, 2, 3, 4, roughly 4.5. My 1, 2, 3, 4. My foci are now outside of those vertices as they were from an ellipse. And once again, my hyperbolas open up around the foci. Now, the last thing it asks for is this transverse axis. And this transverse axis is just the line. They don't call it the axis of symmetry, but it's that idea. The transverse axis is this line that goes straight through the middle of our hyperbola, which is just y equals here is y equals k, and here it's going to be an x equals h. So very similar to an ellipse in many ways. So we looked at this example already. Now let's consider another example, and I'm going to save us some time and consider this graph here. So if I get rid of some of the graph here, let's go through this one and you will see how similar these are. Now, one of the things you'll notice, so as we go to graph this, you'll notice our A is 4, our B is 2, our center is 1, 2, our C equals the square root of 20. All of that is exactly the same from our last example. The difference is going to be with the y first, it's now going to open up or down. So that means that this point up here is my vertex. And down here is my vertex. And it means this graph is going to open up here and open up down here. So as I look at my vertices, I'm going to add and subtract my A to my y coordinate. My foci, I'm going to add and subtract C to my y coordinate. And then that tells me that my foci are 1, 2, 3, 4. 1 is about here, 4.5, and then 1 is about here. And you notice because my foci is much closer to my vertex, this hyperbola is much narrow. My first example, they were further away, so it was much flatter and wider between these. So you can see very, very similar to an ellipse. So let's look at another example here. First question is we want to think about what's our center and what's our direction. So the center here is 0, 1. And my direction, because y is first, this is going to open up and down. My A is 3. My B is 2. My C, you add those together and take the square root, is the square root of 13. So I can fill these in over here. My vertices are 1 plus or minus 3, and my foci is 0, 1 plus or minus square root of 13. Now let's look at the graph. My center is at 0, 1. In the y direction, I go up 3 and down 3. In the x direction, I go left 2 and right 2. Now my vertices, since this opens up or down, are here and here. Now, we draw the box, whether you make it solid or dashed, doesn't really matter. This box is not part of the graph. It just helps us to draw it. Now we draw the diagonals. Now, if we draw the second asymptote or diagonal for this box, and we finally can draw a hyperbola, we use these asymptotes through our vertices to get our general shape. So, very, very similar to an ellipse. Same kind of moving left, right, up, down. It's a little bit different now that we get this box. If we draw our vertices here, square root of 13 is a little bit more than 3, so we'd go 1, 2, 3, and so that would give us our foci would be somewhere here and somewhere there. Once again, the hyperbola opens up around. So the thing to notice is it's hard to tell looking at the box and looking at the asymptotes on which way it opens. If we look at this box, the y is first, it opens up or down, and we look at this first example, the x is first and it opens left or right. The box and the asymptotes are exactly the same. So it really comes down to, is the x first, so the a is underneath the x, or is the y first, so the a is underneath the y. So it's a little bit different than ellipses where your A was always the biggest one. Here, your A would be 2 because it's always the first one. All right, we are now able to do homework over hyperbolas. This is 10-4, part 1.